So in these couple examples, we are going to be looking to do the derivatives, which might involve product rule, quotient rule, combination. Let's see what we got going on. So on this thing, we have a product rule between the two. So you have this times this. So to do the derivative, we are going to do, well, before we do any of this, let's rewrite the root. Don't really, I basically need powers on these things in order to do these derivatives. So this is really z to the 1/3 power times e to the z. All right, now we're ready to go. So product rule is the derivative of the first. So we have a power comes in front. So 1/3 z, and we're going to subtract 1 from it. So it's 1/3 minus 1, which is really 1/3 minus 3/3, which gets us a negative 2/3. So the derivative of the first times the second plus the first times the derivative of the second. And the derivative of an exponential, at least this one, is just going to be itself. All right, so last little bit of this is let's do a little bit of cleanup, see what we can do. Typically, we're probably not going to leave a negative exponent. Not that this is wrong, but usually there's a little bit of cleanup and there's some extra things that typically go with this problem eventually. So we might as well get some good habits. They each share this e to the z. So let me factor that out. All right, so they'd be gone on each of those. And then this piece, I'm going to take this z to the negative 2/3 and bring it into the denominator. And the 3 is in the denominator. So I'm going to have a 1/3 e to the 2/3. And then plus that one away because we factored it out, plus just a z to the 1/3. That's it. We're just going to leave it like that. All right, the only other thing that they may want you to do is because it started as a radical, we may need to do this, a cube root of this, and we may need to do, sorry, I don't know why that's an E, that should be a Z. Or we could do the cube root of Z squared. So there's definitely ways that we can rewrite this, but we're just gonna leave ours like that. And then we're gonna do this one. And so this one screams quotient. There's really nothing I can do to avoid that. So we're going to be doing the derivative of the top. So we're going to take the 5 halves and multiply it to the 3, which will make 15 halves e. And then we're going to take 5 halves minus 1. So 5 halves minus 1 is really minus 2/2. So that's 3 halves. Where are my e's coming from? X to the 3 halves. So the derivative of the top times the bottom, 2x squared plus 4 minus derivative or the top, 3x to the 5 halves. And then times the derivative of the bottom. The derivative of the bottom just turns into 4x. And then that is all over the denominator, 2x squared plus 4 squared. All right, so now the cleanup phase kicks in. So we're going to take this and distribute it in. And when we multiply the 15 halves times the 2, the 2's will cancel. So we're going to have 15. And then we need to add those exponents together. So I have a 3 halves. And we're going to be adding a 2, which is also 4 halves. So that's going to become 7 halves. So that's the first one distributed. The next one distributed is we're going to take the 4, divide it by the 2, multiply by the 15. So that's 2 times 15 is going to turn into 30. And then it's just x to the 3 halves. So that's that piece distributed. And here we're going to have a minus 12. We got 5 halves plus 1, which is 2/2. So 5/2 plus 2/2 is 7/2, which is a like term. So we'll put that together here in a second. So over that denominator squared. All right, I think the last piece is These two are like terms, so 15 minus 12 is going to get us a 3 x to the 7 halves plus 30 x to the 3 halves divided by 2x squared plus 4 squared. And that is as far as we could take that. So that is our slope equation, our derivative of this original.